So first, let's calculate security A's expected return. So the expected return when we're dealing with ex ante data, well, we're making predictions about the future. So there is some uncertainty about these different states of nature, and there's probability estimates associated with each one. The expected return, we just want to multiply the probability that each state of nature occurs times the return that A would get if we ended up in that state of nature. So let's look at this. The expected return for security A, well, there's a 50% chance that we're going to end up in the first state of nature. So we multiply the 0.5 times the return that A would earn in that first state of nature, the 15%. And we want to do that for all three and then add them up. So we add the 30% chance that A will earn 14%, and then the 20% chance that A will earn 25% return. So the numbers inside the parentheses are the returns. The numbers being multiplied then by them are the probabilities for each state of nature. When we add all them up, we get an expected return for security A of 16.7%. And so this is not really, it's not what we expect to earn, maybe in the sense that we would normally think of using that word, because we're not going to get 16.7%. We'll either end up in this first state of nature, which means we get 15%, the second state of nature, which means we get this 14%, or the last state of nature, which means we get 25%. So what is the 16.7? Well, it's really like an average. If we were to face these three states of nature year after year after year, well then on average we would get this one 50% of the time, we would get this one 30% of the time, and we would get the 25% return 20% of the time. So that would average out to about 16.7% return per year. This is what the expected return is telling us. We want to do the same thing for security B. So security B has a 50% chance of earning the 20% return, a 30% chance of earning the 14% return, and a 20% chance of earning a 15% return. When we multiply those and add them together, we see security B's expected return is 17.2%. So on average, it does better than security A. Since the portfolio is composed of 40% of security A and 60% of security B, the portfolio's expected return is, we multiply the security A's expected return, the 16.7, times the 40% that it makes up the portfolio of, plus the 60% weight in security B times the 17.2% that security B is expected to return. And we find that the expected return of the portfolio is 17%.